All right, here we go. So you're all being recorded. So be careful what you say. All right. So let's start out by finding the x and y intercepts of the graph. So what is my you okay? What am I let's start with x intercepts. We'll just call it Ugo first to give her some adrenaline.
All right.
What are my x intercepts here?
Positive 4.
4.
1 and 2.
4. 1.
1 and 2.
1 and 2. Those are. Did I write the question down properly? Yes, I did. Okay, so 4, 1, and 2 are my intercepts, right?
Should I say multiplicity?
Okay, so those are my intercepts. And yes, I would like to know what is their multiplicity.
For 4 it's 30.
4 is. So I'm going to write here mult.
For 1 it's 2.
For 1 is 2.
And for 2 it's 1.
For 2 it's 1. And so if I want to know whether it's a touch or a cross, don't answer this one yet. Let's go to somebody else. Christina, you're out. Gina, you're out. That's good. Let's see. You want to answer?
Sure.
Go ahead. Okay. Touch or a cross on 4.
Okay, well, even you said was touch, so it's cross, touch, cross.
Cross, touch, cross. Very good. I think so. Okay, so let's kind of draw them on there, right? So I have one at 4, and one at 1, and one at 2.
Well, do you also have negative 1?
Do I have one at -1?
Yeah, don't you?
Why do you think I would have one at -1? Because of this right here?
No.
Well, no, but I think what you're thinking is that this is x squared minus 1 as opposed to x minus 1 squared. Right? Because x squared minus 1, x plus 1, x minus 1. That's correct. That's great. But you have to look at the problem carefully. Okay? So those are our 3 intercepts. Are there any other x intercepts that we can visualize here?
No. No, either.
No. Okay, so what is our y intercept?
100.
What is what?
128.
It's 128?
Yep.
Okay. Yes, we want to get yes. So y-intercept is where x is equal to 0, 0, 0, right? Y-intercept is where x is equal to 0, right? So that means this is going to be, I'll write it down here, this is going to be -4 cubed, and this is going to be -1 squared, and that's going to be -2 squared. You see that, Megan? Yeah? Okay. So -4 cubed is -64, right? So that's -64 times -1 squared, which is just 1, times -2 squared, which would be 4. Whoa.
It's not squared. It's not -2 squared.
Oh, it's just -2. I'm sorry. Thank you. Good catch. Okay, so it's just -2 times -2. So, yes, -64 times -2 is positive 128. So, I have a y-intercept somewhere up here, way up in the stratosphere. Okay? So now I found my x and y intercepts. What is the multiplicity? We've already figured out the multiplicity of each 0. Okay, so then we've already determined whether it crosses or touches at each intercept. Right? So we're just zooming right along here. End behavior. Okay. So what's our end behavior going to be? What is the power of this function here? It's 6. You see it? 3, 5, 6, right? Because that's a 1, right? So what's the end behavior? Up?
Yeah.
Okay. So if our end behavior is up, what's going to happen from 4 going towards positive infinity?
It's gonna go.
It's going to go up, right? And what's going to happen at 4? Is it going to touch or cross the x-axis?
Cross.
Okay, so that's an interesting thing here, right? So we know it's going to start down here, and it's going to end up going like that somewhere, right?
Yeah.
We don't know what's going to happen other than that right now, but we know that, right? And what about our far left intercept of -1?
Cross and go out.
Cross and go out. Okay, so we know it's going to go like this.
Oh, no, wait.
One is gonna touch.
No, one is
touch.
touch.
Sorry, one touches.
You're right. 1 is a touch. Mm.
Cross.
So it's going to go here. It's going to go like that. Okay, so we're okay with that?
Yes.
Okay. Although we have a problem.
34, 6, right?
I'm sorry, what are we talking about?
Oh, sorry, I can see the point, but it's -4. No, on the one left. That point.
That little dot right there?
No, this.
Come touch.
Oh, 5. Oh, sorry.
It's a good hopping.
Ooh, I fixed it. Never mind.
It was just
Oh, okay.
just where it happened to hit, right? Now, there's a problem with this. I need to touch the y-intercept from here,
Oh,
right?
so you just.
So really, it's still going to be up, right? But it is like way up, right? It's kind of like, and it's a touch there, so it's like kind of, like way up there. Okay? But it's up. We're okay with up. Everybody with me here?
Yeah.
Okay. So, I got the end behavior. I know what that's going to look like.
Turning point.
Pardon me? How many turning points? What's the maximum number of turning points I can have?
5.
Okay, so my max turning points is 5. Max TP is 5. And what did we say it's going to do at 2? It's going to touch.
Cross.
And our intercept 2, it's going to cross. That's kind of interesting.
maybe it goes.
And at 1 here, it's just a touch, right?
Yeah.
So at 1 there means it's going to kind of go up like that somehow, right?
Yeah. And then come back.
And then it's going to come back down, huh? I think so too. I think it's going to come back down, and it's going to cross, and it's going to turn around there. Does that look about?
Yeah.
The only way to know where it turns is to use your calculator and calculate minimum and maximum.
So you're just like winging it right now.
I'm totally winging it right now. Totally, in terms of what the actual things are.
Yeah.
But, and this is kind of why I like the previous question, because even if I'm totally winging it, I can answer the question, where is it above or below the x-axis? I can answer that. It's not, if I don't have to answer how high above or below it is from the x-axis, right? But so we're saying that our graph should look kind of like this, is that right? Well, let's find out. Well, so actually, let's do this. Where is it above? I want to describe where it is above the x-axis. So, there we go. How do I describe it? Where is this graph above the x-axis? Give me the interval notation.
Negative infinity. Parentheses. 1.
Comma.
Parentheses.
1. Parentheses.
Union. 1. Or wait.
No, I think you're right.
1. 2.
I think you're right. Uh-huh.
Union. 4.
I think that's correct.
Oh, wait.
Everybody follow that?
So these are intervals. Above.
That's our interval for above. Okay. So Nicole, what is our interval for where it is below the x-axis?
4.
I think that's correct. 2, 4. I don't think there's any place else that it's below.
Yeah.
I think there's some space, there's some spots where it is equal to, right? But notice, forgetting about the points where it's exactly equal to the x-axis, we have gone negative infinity to 1, 1 to 2, 2 to 4, 4 to infinity. We have covered the entire x-axis from negative infinity to infinity.
Should we do that with every interval notation?
Well,
I mean, with every.
I mean, it would really depend on the question. Because if I just said, you know, I want to know where it's above the x-axis, then no, you wouldn't have, you know. But if it's saying where's it above and below, you know, yeah, then it should work out like that. Right.
I have a question.
Yes.
What is the difference between D and E?
D in behavior, based on the power, it's the same.
Okay.
Although D is kind of saying what is the power function that this graph resembles. So what is the power function that this graph resembles?
Oh.
Well, not exactly. You would say x to the 6th.
Oh, the parent function. Okay.
Right. That's kind of like
Parent function
the,
is R1.
it would be x to the 6th. Yeah. So let's see if you guys got this really quickly. Oh, I don't know. The last period, we spent a lot. I don't know what we were doing last period. Maybe we were just fooling around with other stuff. But we did not have a lot of time at the end of class. So let's go. Why? Yeah, still recording. So x minus 4 in parentheses caret 3. And then we have x minus 1 n parentheses squared. And then we have x minus 2, no power, right? X minus 2, no power. Let's go zoom 6. It's not going to show us much.
It does.
Oh, it does. It shows us the whole thing. So, and that is, you know, I mean, that's a reasonable facsimile. I say that's a reasonable facsimile. So, okay, now I'm going to turn this off.